Proxima Centauri, gateway to a potential second Earth. Proxima Centauri, the closest known star to our solar system, has long fascinated astronomers. This small red dwarf, discovered in 1915 by Scottish astronomer Robert Innes, is part of the Alpha Centauri star system, which also includes Alpha Centauri A and B. Despite being only 4.24 light-years away, Proxima Centauri is invisible to the naked eye due to its low luminosity. What makes Proxima Centauri scientifically significant is its role as the host star of Proxima b, an exoplanet that orbits within the star's habitable zone. Red dwarfs like Proxima Centauri are smaller, cooler, and live far longer than stars like our Sun. Their low brightness means their habitable zones lie much closer to the star. In the case of Proxima Centauri, Proxima b orbits at just 0.05 astronomical units EU, a small fraction of the distance between Earth and the Sun. However, this close orbit exposes Proxima b to intense stellar activity, including frequent solar flares and high radiation levels. These harsh conditions make its environment quite different from Earth's. The discovery of Proxima b in 2016, confirmed by the European Southern Observatory, was a major breakthrough in the search for habitable exoplanets. Using the radial velocity method, astronomers detected tiny wobbles in Proxima Centauri's position caused by the gravitational tug of an orbiting planet. These measurements help determine the planet's mass and orbital period. Ground-based telescopes have provided valuable data about Proxima b, but their observations are limited by atmospheric interference and light pollution. Most of what we know, such as the planet's mass, orbital distance, and potential composition, comes from indirect methods. To gain deeper insights into Proxima b's surface, atmosphere, and potential for life, more advanced observational tools are essential. Enter the James Webb Space Telescope JWST, a revolutionary advancement in astronomy. Designed as a successor to the Hubble Space Telescope, JWST was built to overcome Hubble's limitations and greatly expand our understanding of the universe. While Hubble focuses mainly on visible and ultraviolet light, JWST observes primarily in the infrared spectrum. This allows it to see through cosmic dust and detect celestial phenomena that are invisible to Hubble. One of JWST's most impressive features is its primary mirror, which spans 6.5 meters in diameter, more than twice the size of Hubble's. Made of 18 hexagonal segments coated in gold to enhance infrared reflectivity, this mirror enables JWST to capture faint light from distant galaxies and exoplanets. The telescope is also equipped with a 5-layer sun shield that keeps its instruments at a frigid minus 233 degrees Celsius, essential for detecting weak infrared signals without interference from the telescope's own heat. Unlike Hubble, which orbits Earth, JWST operates from the second Lagrange point, L2, located about 1.5 million kilometers away. This stable position reduces interference from Earth's heat and light, allowing for continuous and unobstructed observations. JWST is capable of studying everything from the earliest galaxies to the atmospheric compositions of exoplanets, like Proxima b. Its infrared capabilities are especially valuable for observing redshifted objects, those whose light has been stretched as the universe expands. With instruments like the near-infrared camera NIRCam, mid-infrared instrument MIRI, and near-infrared spectrograph NIRSpec, JWST functions not only as a telescope but also as a time machine and a scientific laboratory. Proxima b has captivated both scientists and the public as a possible second Earth. Located within its star's habitable zone, it may have the right conditions to support liquid water, an essential ingredient for life. With a mass approximately 1.17 times that of Earth, it is likely a rocky planet, similar in composition to our own. Its relative closeness, just over 4 light-years away, makes Proxima b an ideal candidate for studying the potential for life beyond our solar system. Although its environment is harsh, the possibility of habitability makes it one of the most intriguing exoplanets discovered to date. Proxima b, a harsh but intriguing Earth-like world. Although Proxima b lies outside our solar system and shares some similarities with Earth, it is far from a perfect twin. One of its most remarkable traits is that it is tidally locked. One side constantly faces its star in perpetual daylight, while the other side remains in eternal darkness. This creates extreme temperature contrast between the two hemispheres. However, The Terminator line, the narrow region between day and night, might offer a twilight zone where conditions are moderate enough to potentially support life. Proxima b orbits Proxima Centauri, a red dwarf star known for intense solar flares that emit high levels of X-rays and ultraviolet radiation. These flares could gradually strip away the planet's atmosphere, leaving the surface exposed to space. To retain its atmosphere and shield life from harmful radiation, Proxima b would need a strong magnetic field. Without it, the surface environment would be extremely hostile to life as we know it. Despite these harsh conditions, scientists remain hopeful. Proxima b lies within its star's habitable zone, meaning it could possibly support liquid water on the surface or in subsurface reservoirs. Life, if it exists, might resemble extremophiles on Earth, organisms that thrive in extreme environments like deep-sea hydrothermal vents or high radiation zones. Potential adaptations could include radiation resistance, underground habitats, or unique biochemical systems. The search for life on Proxima b is more than just a scientific mission. It touches on one of humanity's oldest questions. Are we alone in the universe? This rocky, Earth-sized world presents a compelling case for further exploration as our technology advances and allows us to study it in greater detail. Proxima b's environment is deeply shaped by the nature of its host star. Unlike our Sun, Proxima Centauri is a red dwarf, smaller, cooler, and much less luminous. As a result, its habitable zone is much closer in. Proxima b orbits at only 0.05 astronomical units from its star, roughly 20 times closer than Earth is to the Sun. This close proximity brings with it serious challenges, especially due to the star's frequent and powerful solar flares. These flares bombard the planet with high doses of radiation, which could erode its atmosphere unless Proxima b has a protective magnetic field. Even if some atmosphere remains, the radiation could hinder the development of complex organic molecules, making the surface inhospitable to life. However, some hope remains. On Earth, organisms like Deinococcus radiodurans have evolved mechanisms to repair radiation-induced DNA damage. It's possible that life on Proxima b, if it exists, has evolved similar or even more extreme adaptations. The planet's tidally locked nature might even provide a partial shield. While the day side receives constant radiation, the dark side could offer a safer haven. Underground environments, deep caves, or subsurface oceans may offer protection where life could potentially survive, similar to ecosystems around hydrothermal vents on Earth. Proxima b's harsh conditions make it more than just a possible home for alien life. It becomes a natural laboratory for studying life's resilience. By examining how organisms might endure or flourish in such an environment, scientists can broaden their understanding of what makes a planet habitable. Its relatively Earth-like size and composition, along with its location in the habitable zone, make Proxima b one of the most promising exoplanets for future study. With the help of next-generation telescopes and instruments, researchers will continue to investigate this distant world in the hopes of finding signs of life. Though the path is challenging, Proxima b offers a captivating glimpse into the possibilities of life beyond our planet, and a reminder that humanity's search for life is just beginning. Scientists are particularly focused on discovering planets with characteristics similar to Earth, as these offer the most promising environments for the development of life. One such planet of great interest is Proxima b, and astronomers are employing a variety of cutting-edge techniques to explore its potential habitability. A key method being used is transmission spectroscopy, which involves analyzing starlight that passes through a planet's atmosphere during a transit. This allows scientists to determine the atmosphere's chemical composition by identifying specific absorption lines in the light spectrum. The detection of gases such as oxygen, methane, and carbon dioxide, often linked to biological activity on Earth, could be a strong indicator of potential life on Proxima b. In addition to atmospheric analysis, researchers are also investigating the possibility of microbial life beneath Proxima b's surface. The idea of subsurface life has gained credibility with the discovery of extremophiles on Earth, organisms that thrive in harsh environments like deep-sea hydrothermal vents and acidic lakes. If Proxima b harbors subsurface reservoirs of liquid water, such as aquifers or oceans, it could provide a stable and protected environment, shielded from harmful solar radiation and flares emitted by its host star, Proxima Centauri. Beyond the search for life, Proxima b presents a valuable opportunity to better understand the interactions between planets and their host stars. Located within a habitable zone, Proxima b allows scientists to study how stellar activity, particularly the frequent solar flares from Proxima Centauri, might influence a planet's atmosphere, climate, magnetic field, and overall ability to sustain life. Though research on Proxima b is still in its early stages, technological advancements, such as the James Webb Space Telescope JWST, are opening new doors. With its powerful infrared capabilities, JWST will enable more detailed analysis of the planet's atmosphere, surface, and potential signs of habitability. Ultimately, the study of Proxima b goes beyond the question of whether alien life exists. It is also about deepening our understanding of what makes a planet habitable. Insights gained from Proxima b can be applied to other exoplanets, expanding the scope of our search for life across the universe. Moreover, this research enhances our knowledge of planetary formation and the evolution of star systems, especially those involving red dwarf stars like Proxima Centauri. These stars, which are the most common in our galaxy, present unique challenges and opportunities in the formation of planetary systems. As new missions and technologies continue to emerge, Proxima b will remain a cornerstone in the quest to find habitable worlds. Whether or not life is ever discovered there, the exploration of Proxima b will significantly contribute to our understanding of the cosmos and our place within it